In today's video, we're going to walk through an example of how to use the code-first development model of AutoQuery and Locode to rapidly build an extensible line of business application. ServiceStack Locode enables developers to build line of business applications quickly by generating functional services directly from an existing database schema or from a database and API models being declared in C#. Developers can also quickly switch between these development models as steps along the way to avoid wasted effort. For example, starting with a database schema only and migrating to a code-first approach by getting ServiceStack to generate the C# code directly from your application and connected database. In a previous video, we walked through the use of the database first model using the Northwind sample database and make customizations to the metadata dynamically on startup. From there, we can also generate the C# code required for the same functionality directly from our ServiceStack application. The code-first approach is easier to maintain the customization as your application grows, since they are declarative and are applied directly to the related classes and properties. So today, we are going to use the Chinook sample database to do exactly that. Start with an empty ServiceStack application, add an existing database, migrate to a code-first approach, and apply customizations to our low-code application. These customizations are applied by using C# attributes against the database model classes and the request data transfer object classes directly. We will use the Chinook sample database as a SQLite database, but this technique using low-code also supports Postgres, MS SQL, and MySQL databases. To follow along with these steps, you will need two things installed: the .NET 6 SDK and the ServiceStack.NET X tool. If you don't have the ServiceStack.NET X tool installed, you can install it using the command .NET tool install-gx. To get us started, we'll want a simple web application setup with ServiceStack. We can do this by generating a project from the ServiceStack website. Going to ServiceStack.net and clicking on Get Started at the top right will bring you to a template generator that helps you to configure the project you want to start with. We will start with an empty web template so we can show the steps required. Provide a name for your project and click on the web template to download a zip of your newly created solution. Once your template is downloaded, you will need to unzip the solution into a directory on your local machine where you want to work from. Opening in your favorite .NET IDE, we will see a solution with 4 projects. This is a standard setup for ServiceStack templates, which consists of your app host project, your service interface project, your service model project, and your tests project. The app host project is where you configure your application, and since we will be using AutoQuery to kickstart the process by generating our database and related API models, this is where we will want to make our initial changes. The .NET X tool can mix in common features to your application using templates. For example, we want to add SQLite support and AutoQuery to our application, and we can do this with the command xmix space SQLite space AutoQuery. We will also mix in the Chinook.SQLite sample database for ease of use by running the command xmix space Chinook.SQLite directly in our app host project folder. Once we have mixed in SQLite and AutoQuery, we will get 2 configure classes, configure.db.cs and configure.autoquery.cs. Configure.db.cs contains our configuration for the SQLite connection and ORM-Lite provider options. Here we can see we are using memory as the connection string to our SQLite in-memory database. We will want to change this to connect to our sample database, which is the Chinook.SQLite file in the app host project. So now we have a database connection factory registered with our app host. We can configure AutoQuery to use our database schema to generate services dynamically on startup. To configure AutoQuery to do this, we will instantiate the generated CRUD services property with the auto register flag set to true. The AutoQuery feature plugin will automatically use your registered IDB connection factory to communicate with your database and generate services for the tables in the public schema. Once running, we can use the X tool to use these dynamic services to generate our C# model classes, where we will no longer need AutoQuery to perform this dynamically. This is just a quick way of getting started with the code-first approach while also having an existing database to work from. We are getting ServiceStack's code generation capability combined with generated CRUD services to kickstart our project with clean, plain old C# object classes or POCOs for our service model project. And you can do this code generation step at any stage with runtime customizations preserved in the generated C#. This iterative development model that Locode enables means you can get your changes and solutions in front of clients or stakeholders quickly while still having a small codebase that's easy to maintain and extend for .NET developers. By running your application and going to /metadata, we can verify that our database tables we want have been generated and we're ready to migrate to a code-first approach using the ServiceStack X tool. The ServiceStack X tool is calling your locally running ServiceStack application to generate the equivalent C# database models and autoquery request DTOs. We will save the generated output to a file in our service model project, since the generated POCOs can be safely shared between our ServiceStack application and any clients. We can do this by running the following command from our service model project directory: x_c# space the path of your locally running ServiceStack application -path space /crud/all/c#. This step of migration is also configurable from your server itself. For example, the use of data contract everywhere in our generated code is something we don't need, since these classes will be replacing the dynamically generated ones rather than being used by a client with serialization. We can remove this from the generation by changing the generated CRUD services on the server to have the option add data contract attribute set to false. Rerunning our server and regenerating our models, we start with cleaner POCOs. After generation, they are all in a single dtos.cs file, but let's split them up between our database models and our DTOs to start with. Our database models can be moved to a new models.cs file in the types folder in the service model project. This means we have our database model POCOs all in one place and our request DTOs in another to apply our customizations. Now if we go back and disable generated CRUD services and let autoquery use our code-first DTOs, we end up with the same result, except this time our code is driving the functionality and we are ready to apply our customizations. If we rerun our application and navigate to the /metadata page, we can see that all of our now code-first services are listed as before. Clicking on one of these services will show you the service in API Explorer, which is built into your ServiceStack application. This presents the metadata about your APIs for developers to make them easier to consume. At the top right of the screen, you'll also see a View in Locode button when selecting an autoquery service. Clicking on this will take you to your Locode application, which provides a user-friendly way to manage the data using your autoquery services. On the left, each set of 4 services is grouped by your table, enabling you to filter, sort, and navigate between related tables from the built-in menus. For example, if a back-office staff member wanted to see the most recent sales grouped by customer and are only interested in a few specific columns, we can do that by applying the sort to invoice date and then customer ID, and then filtering only the columns we're interested in. Here we can also change the number of rows per page, and the paging controls themselves are at the top of the table. Additionally, if we're only interested in sales after a specific date, we can apply a filter on invoice date to filter old invoices. Multiple filters and sorting can be combined, and existing filters can be managed or removed using the top table menu or cleared using the Reset Preferences and Filters button. If the data model has a corresponding autoquery service for create, a plus button will be available to create rows from a generated form. Creation of rows using the default generated forms also infers controls based on the data type in the columns of your database schema. Same goes for the updating of data as well. Snapshots of your current view can be exported to Excel in CSV format using the Excel button at the top. And if you want the API URL that generates the same view of data, the Copy URL button will give you an API URL with the same filtering and sorting preferences. All this functionality so far has been from the generated code from the initial autoquery and generated CRUD services configuration. And this code is just like any autoquery services you might write. Locode works with autoquery services regardless of how they were made. We are just leveraging these features and code generation to get started quickly. At this stage, if you want to exclude some operations for a table that you don't need some autoquery services for example, if you want to make a table read only, we can just delete the autoquery DTOs related to that operation. Now let's look at some visual changes we can make to our low-code app. As a developer, if you know what customizations should be done for a client, you could jump into the code and make those changes straight away. But one big advantage of low-code is that you can show a concrete working CRUD application to stakeholders and clients to get immediate feedback of what should and shouldn't be included in the application. Let's say we showed this project as it is to the client and we got back some pretty obvious improvements that they want. The top needs their custom branding, media and store operations should be grouped on the left side, they should be able to look up related table information without knowing the ID, data like money, time and file size should be more appropriately formatted, and contact information like phone numbers and emails should be clickable. Going back to our project, let's implement these changes. To change the branding at the top left, we need to change the UI feature plugin. In the apphost project, configure.apphost.cs has our apphost class and configure method. We can use the configure plugin T method to select plugins registered by default and change their options. By instantiating info.brand icon on the UI feature, we can provide a custom image info specifying a URI for our custom logo SVG and CLS property for custom CSS classes. Here we're using some Tailwind CSS that is available in the low-code app automatically. Rerunning our application and we'll see the new branding in the top left. With our first task done, next we want to group media and store related services on the left menu. Here we can use the tag attribute on the autoquery request DTOs to put them in their own category. The left-hand menu in low-code will show services with the same tag string together, enabling us to group them between operations for media and operations of the store. Once we have applied them to all our request DTOs and run our application again, we can see we have media and store drop-down menus on the left with our related services. Third on our list is to enable lookup fields in the low-code app to avoid needing to provide IDs manually. If the database schema follows the same conventions as ORM Lite for foreign and primary key names, this functionality can work out of the box, but for setups with different naming, we can use the ref attribute on our model classes to add the required metadata. For example, in the Northwind demo, this lookup functionality worked by default even with the generated services, since it followed the same key naming conventions, so we can use implicit references. Here in our Chinook application, we are just seeing ID column values for foreign keys, so let's change that so we see lookup values instead. The ref attribute allows us to relate the foreign key columns to the source table as well as control the column data we want to present in the low-code app in its place. For example, in the tracks database model class, we can use the ref attribute on the album ID, media type ID, and genre ID to their related tables. To avoid the use of fixed strings, we can use the name of keyword providing the model of albums, ref ID of albums.albumID, and ref label of albums.title. Model is the name of the related table, ref ID is the name of the related column, and ref label is the name of the column data we want to present instead. Applying the ref attribute to the 3 foreign key properties in the tracks class and running our application, we can see the label data coming through as well as the ability to look up these fields in the create and update forms. Fourth on our list of improvements is data formatting for columns dealing with money, time, and file size. Scrolling to the far right columns of tracks, we can see milliseconds, bytes, and unit price listed. Although these 3 columns reflect the data in the database correctly, they aren't the easiest to read. We can attribute these columns as well to format the data better for the low-code app interface. By applying the INTL datetime attribute to our C# database model class properties, we can leverage the built-in standard JavaScript API in the browser as this attribute maps to the INTL datetime format method. The minute, second, and fractional second properties in the C# INTL datetime attribute map onto the options object of the browser call, giving us a nice format for the length of the track. For the unit price, we can use the INTL number attribute, which also maps to the INTL JavaScript API in the browser. This gives us internationalization for currency, and we can set the currency property of the attribute to numberCurrency.usd. Lastly, there's the bytes property. We can present this in a user-friendly way using the format attribute and specifying the format methods.bytes constant. The format methods constant provides a list of built-in methods like bytes which we can use for formatting the size of the track file. We can use the format methods link phone and link email on the employees table as well. This knocks off the last requirements in our list, and the link email can take options to control the subject of the mail to link it creates. These constants are strings that match a JavaScript method name on the client and can be passed a single options property string containing a JavaScript object. The JavaScript functions in the format methods class are already registered with your low-code application, and you can define your own format methods for your low-code application using a predefined custom.js file in the path www.root/modules/lowcode directory. By creating a custom.js file in this path, your low-code application will load this file so that your own format methods are ready to use. For example, if we wanted to use a custom style for making the track name stand out a bit more, we could declare a stylized JavaScript function that wraps the value in a styled span. We can make this functionality reusable by making the CSS classes come from the format attribute via the options string, which uses a JavaScript object notation. Applying the format attribute with the name of our method stylize with the options we want and rerunning our application, we can see the name of the track now stands out in a different color. So we now know we can change the presentation of our data in low-code by using the ref, intl, and format attributes applied to the properties of our database model classes. And we can also customize the create and edit forms as well. To change how our staff might input data, we can use the input attribute applied to the create and update request DTOs. These will change the related create and edit forms for a specific property and control. For example, if we wanted to add placeholder text to our create artists in the name property, we can specify the input attribute with the placeholder value of name of artist. And if we look at the C# input attribute, we can see we have all the same attributes available that are on the input HTML element. So we can control any HTML element attribute just by applying it to the C# equivalent. If you need more control, we can even override the create and edit forms entirely and provide a custom form for the create and edit actions. In the same directory path as the custom.js file, we can also provide a custom.html and custom.css file, which will automatically be loaded by low-code. You can create your components in the custom.html file like we can see here for the create album form. Low-code matches the name of the component with the operation being performed. For example, to override the create album form, we need to register a component with the new prefix followed by the model name of albums. So to override create tracks, we would call the component new tracks. The same pattern is used for the update operations, but this time using the edit prefix like edit albums and edit tracks. Customizations for low-code components are all done in JavaScript built using the Petite Vue library, but we can also benefit from development time TypeScript tooling using the TypeScript definitions. These are available via the ServiceStack UI NPM library, which can make using the ServiceStack UI API for low-code customizations easier and have autocomplete and static analysis at development time thanks to TypeScript. By combining this with the Add ServiceStack reference feature, we even get typed end-to-end usage of your ServiceStack services for making customizations to your low-code application. For an example of this, in the Chinook demo, it also has an overridden welcome page template, which is displayed at the root of the Locode app. Looking at the code for this customization, we can see the statement at the top of the file, import query invoices from DTOs. As we can see in Rider, this enables a great developer experience since all the type information can be used to enhance the static analysis during development. Petite Vue doesn't use any JavaScript compile steps, so these import statements are stripped before getting to the client, and to be correctly identified should be a single-lined import statements and not have any preceding whitespace. The full documentation of the ServiceStack UI API for low-code customizations is available at api.lowcode.dev. Locode provides a flexible development model that enables developers to start quickly and adapt their development efforts based on early user feedback. In this example, we started by generating our code-first models from a database schema and extending them directly with the use of C# attributes on the model and request DTOs. This gives us a declarative way to customize our low-code application that relates straight back to the database models and API contracts, making them easier to maintain. The Locode App UI also already integrates with high-level server features in ServiceStack, enabling audit, authentication, validation, user management, managed file uploads, and more. And even if you find during your development you need your own custom UI, Locode is interacting with auto query services, which are all discoverable in API Explorer with client generation available in 9 languages. ServiceStack's low-code app and related features are growing, so we can provide developers a way to produce API-driven systems quickly that become the foundation of your applications. Check out lowcode.dev for more information and let us know what kind of features you would like to see added. Well, that's it for this video. If you have any suggestions or feedback about our templates or videos, let us know in the comments. If you want to learn more, check out our other videos and join us in the ServiceStack community through our Discord and GitHub discussions. ServiceStack is free for individuals and open source projects, so anyone is welcome. And as always, thanks for watching.